Hello, everybody. This is Dr. R. Sasikumar, Professor, Computer Science and Engineering Department, RMDEC Engineering College. Today, I am going to take about basic operational concept in computer architecture. So, before move on to this topic, for example, suppose if you want to get or if you want to execute one instruction, then how the instruction will be executed? Then what are the steps to be required to execute that instruction? So, those things we are going to learn this video. To perform a given task, an appropriate program consisting of list of instructions is stored in the memory. So whatever the user gives the input, everything will be stored into that main memory. So the user has to write the program which contains n number of instructions. All the instructions are available in that main memory. So individual instructions are brought from the memory into the processor, which execute the specified operation. Suppose if you want to execute one instruction, we have to get the instruction from main memory and do the necessary operation with the help of ALU. So data to be used as an instruction operand are also stored in that memory. After executing that instruction, then the final result also will be stored into that memory. So the memory is a very important thing that which contains both instruction as well as data. For example, load R2 comma LOC. So here LOC represent what location? R2 is nothing but what a general purpose instruction register, and load is an instruction name. So this instruction read the content of memory location whose address is represented symbolically by the label LOC and load them into processor register R2. It means we are going to get the data from the specified memory location. After getting the data from the specified memory location, that data will be transferred or will be stored into the general purpose register R2. So the original content of location LOC are preserved, whereas register R2 are overwritten. So the LOC content will not be changed, but the R2 content will be changed. So execution of this instruction requires several steps. First, the instruction is fetched from memory into the processor because all the instructions are available in memory. So before executing one instruction, we have to fetch the instruction from the memory for doing the processing. After fetching the instruction, next the operation to be performed is determined by the control unit because the system doesn't know what type of instruction is currently available. So after fetching the instruction, with the help of the necessary control unit, the ALU can perform the operation. The operand at LOC is then fetched from memory into the processor. So after analyzing that instruction, then the system is ready to fetch the operand from the memory into the processor. Finally, the instruction is available and the data also available. So the system can do the necessary operation and the operand is stored into register R2. With respect to this example, we have to fetch the data from the specified memory location LOC and stored into register R2. So this is the connection between the processor and the memory. So in the left hand side, we have an overall architecture about the basic operational concept starting from main memory, and bottom one is CPU. CPU is nothing but what a central processing unit. In that CPU, we have some register. One is IR, that is an instruction register. The second one is a program counter, that is a program counter PC. Then MAR, memory address register. MDR, memory data register. Okay, then R0 to Rn-1, that is called what general purpose register. Then control unit ALU. So we will see one by one. So first, what is called IR? IR is nothing but what instruction register. It holds the instruction that is currently being executed. So what type of instruction is currently available, ready to execute, that instruction will be available in that instruction register. Its output is available for the control circuit, which generates the timing signal that control the various processing element in one execution of the instruction. So what is the purpose of IR means what? Based on that instruction, it will generate the timing signal. So who will generate the timing signal means what? The control unit. The control unit which generates the necessary timing signal to perform the entire operations. So the instruction register which hold the instruction that is currently being executed. The next one, program counter. So this is another specialized register that keeps track of execution of a program. So what is called program counter means what? It always contains the address of the next instruction. It contains the memory address of the next instruction to be fetched and executed. So program counter, that is a always contains the first instruction or address of the next instruction to be fetched and executed. MAR, memory address register, it holds the address of the location to be accessed. MDR, memory data register, it contains the data to be written into or read out from the address location. So MDR is especially used for to fetch the data or to store the data into memory. MAR is especially used for to fetch the instruction from main memory. So MAR, memory address register, it always perform the unique operation. MDR to fetch the data from memory and as well as store the data into memory. So it will perform the bidirectional operation. Then what are the steps required to execute one instruction? So the first step, program resides in the memory and usually get these through the input unit. So user has to type all the information via input unit. After feed that information into that through that input unit, that will be stored into memory. So that is the step one. Program reside in the main memory and usually get these through the input unit. So everything will be available in main memory. Then how it is stored into memory means what? With the help of input unit. The second step, execution of the program starts when the program counter is set to point at the first instruction of the program. Normally, the program counter points for the address of the first instruction. Then, once the instruction is move on to IR, that is the instruction register, then the program counter will be incremented by 4 automatically. So that's why the very first time the program counter is set to point at the first instruction of the program. So because where the instruction is available means what? All the instructions are available in main memory. So with the help of program counter, with the help of MAR, we have to fetch the instruction one by one. Then third step, the content of the program counter are transferred to MAR. So what is the content of the program counter? The program counter points the address of the first instruction. So now that address will be supplied to MAR, memory address register. And what is the purpose of MAR? Memory address register. It is used to perform the read operation or it is used to fetch the instruction from the memory. So the control unit which generates the control signal. What is the control signal name? Read control signal. That is sent to that memory. So after the time required to access the memory elapses, then the address word is read out of the memory and loaded into MDR. Okay. So I will explain once again. The program reside in that main memory. Everything will be available in that main memory with the help of input unit. The second step, the execution is initially started with the help of program counter because the program counter is one type of register that always points the address of the first instruction or the next instruction. Then what is the content available in that program counter means what? Address is available in that program counter. That address which is applied to MAR because MAR is used to fetch the instruction from the memory with the help of control signal. Who will generate the control signal means what? A control unit which generate the control signal. So what is the use of that control signal means what? To read the instruction from the main memory. Okay, so here the name of the control signal is what? Read signal. And after issuing that control signal, then the system will read the instruction from main memory and stored into MDR. MDR is nothing but what? A memory data register. So now the fifth step is what? Now the content of MDR are transferred to IR because the current instruction is available in MDR. That will be transferred to IR. What is the purpose of moving instruction from MDR to IR means what? Instruction register holds the current instruction execution and also to perform the decoding and analyze operation because the system doesn't know what type of instruction is currently available. So we have to analyze that instruction, how many operand is required, everything will be decoded with the help of instruction register. So the step 6, if the instruction involves an operation by the ALU, it is necessary to obtain the required operand. Suppose if the instruction which contains 2 operand, or 3 operand or 1 operand, then we need to get the data. So ALU has to perform the necessary operation with the help of operand. So we need to fetch the operand from main memory. That's why that an operand in the memory is fetched by sending its address to MAR and initiating the read signal. So how to fetch the data from memory? With the help of MAR, a memory address register. So we have to pass the address of the data to MAR, then that will be supplied to main memory with the help of control signal. Here the control signal, name of the control signal is what? Read signal. So to read the data from memory. Once they fetch the operand from that memory, then that will be immediately stored into MDR. Again, later that data will be transferred from MDR to ALU. So ALU is nothing but what? Arithmetic logic unit. It is going to perform the arithmetic operation and the logical operation. So step 9, after 1 or 2 such repeated cycle, the ALU can perform the desired operation. For example, if the current instruction is add instruction, minimum it required 2 data. So after getting the 2 data, then the ALU can perform the addition operation. Here, the example is what? To fetch the data from specified location into R2. So after fetching the data from the specified location, then that will be transferred to R2. So the step 10, if the result of this operation is to be stored in that memory, then the result is sent to MDR, because after completing all the operations, we have to store the data into memory. Then how to store the data into memory? If the data comes means what? Definitely we have to use MDR. So MDR is a bidirectional communication. So via MDR, the data will be stored into specified memory location. Who will specify the address? Because I want to store the data into specified memory location. I have a data, but I don't know about that memory address. So with the help of MAR, the address can be passed to main memory. In that specified memory location, the given data will be stored into main memory. So here, the control unit which generates another control signals, because the system is going to write data into main memory in the specified memory location. So the control unit which generates the write signal. So the last step, the content of PC are incremented. So the PC points to the next instruction that is to be executed. Now the instruction is over. So again, we have to fetch the another instruction. Then how to fetch the another instruction means what? With the help of a program counter, because the program counter is the starting point. So now the program counter points the address of the next instruction. So that program counter will be incremented automatically. Depends upon the process. I hope you understand this concept, basic operational concept. Thank you.